Elon Musk has once again stunned the world, this time not with a car, a rocket, or an energy project, but with something that could redefine the very idea of flight itself. The Tesla aircraft, officially revealed after years of speculation, represents the next frontier in Musk's vision of sustainable high-performance transportation. What makes this reveal so extraordinary isn't just the technology, it's the scope of ambition. This $113 billion project, dubbed internally as the Model A, doesn't simply aim to rival traditional aircraft. It's designed to rewrite the rules of aviation altogether. The story begins with Musk stepping onto a stage packed with journalists, engineers, and investors, his confidence unmistakable. Live streamed to millions of viewers around the world, the event had the same sense of awe and anticipation that accompanied the original Tesla Roadster reveal or the first Falcon Heavy launch. Musk, with his usual understated charisma, wasted no time in setting the tone. "We've conquered the roads, we've touched the stars, and now we're going to revolutionize the skies," he declared. Behind him stood the Tesla aircraft's sleek, polished and gleaming under the stage lights like something straight out of a science fiction movie. The aircraft's design immediately captured everyone's attention. It was a masterclass in aerodynamics and minimalism, clean lines, seamless contours, and a futuristic aesthetic that could only come from Tesla's design team. The Model A looked nothing like a traditional jet. It didn't have the bulky turbines or mechanical noise associated with commercial aircraft. Instead, its smooth surface was covered with microsolar cells, and its propulsion system appeared hidden beneath an elegant metallic frame. Everything about it screamed next-generation engineering. But the real shock came when Musk began describing how this machine actually works. The Tesla aircraft doesn't rely on jet fuel, propellers, or even conventional electric engines. Instead, it's powered by a technology Musk called quantum lift dynamics, a propulsion breakthrough that seems to defy what most people think is physically possible. Traditional planes create lift by pushing air over wings, which creates a pressure difference that allows the plane to rise. While effective, this approach has limitations. It requires long runways, consumes massive amounts of fuel, and generates significant carbon emissions. Tesla's engineers, according to Musk, have developed an entirely new method of achieving lift and thrust. By manipulating electromagnetic fields through a combination of ion thrusters and advanced quantum control systems, the aircraft can hover, silently accelerate vertically, and cruise at supersonic speeds, all without burning a drop of fuel. In essence, this craft can take off like a helicopter, fly like a jet, and land without the need for a runway. The technology blends principles of electromagnetism, plasma propulsion, and regenerative energy flow in a way that no commercial company has achieved before. Musk described the aircraft as the intersection of a plane, a rocket, and a spacecraft capable of vertical takeoff and landing (VTOL) in dense urban environments while also being fast enough for intercontinental travel. Imagine being able to lift off from downtown Los Angeles and land directly in the heart of Tokyo in just a few hours, all without the noise, pollution, or logistical challenges of traditional airports. That's the kind of world Musk envisions with the Tesla aircraft. When it comes to performance, the numbers are staggering. The Model A can reportedly reach speeds exceeding Mach 2s. It's over 1,500 miles per hour, placing it in the same category as the legendary Concorde. What's even more impressive is that it achieves this using pure electric propulsion. And unlike most electric aircraft concepts that suffer from limited range due to heavy batteries, the Tesla aircraft boasts a range of more than 10,000 miles on a single charge. This range is made possible through Tesla's latest breakthrough in energy storage, the Maxwell Supercell. It's named after the Tesla subsidiary responsible for next-generation battery innovation. The Supercell is an ultra-dense, ultra-efficient energy unit that not only holds far more charge than lithium-ion batteries, but can also recharge itself in flight through integrated solar energy recovery systems. Essentially, the aircraft's surface acts as a solar panel, constantly feeding power back into the battery as it flies. Combined with advanced regenerative braking systems in its thrusters, the aircraft maintains a near-perpetual energy cycle during long-distance flights. The implications of this are massive. Long-haul flights, which traditionally consume thousands of gallons of jet fuel and produce massive carbon emissions, could become fully sustainable. Imagine crossing the Atlantic without releasing a single gram of CO into the atmosphere. According to Tesla's engineers, the Model A's energy efficiency is so advanced that it generates less noise pollution than a city bus, and its environmental footprint is virtually zero. This marks a major shift for an industry that contributes roughly to 5% of all global CO emissions. Commercial aviation has been one of the hardest sectors to decarbonize because of the immense energy required for flight. Batteries that could support large planes were either too heavy or too inefficient. Till now, Tesla's solution, through lightweight materials, electromagnetic lift, and regenerative power systems, effectively eliminates those barriers. The Tesla aircraft isn't just about cleaner travel, it's about faster and more accessible travel. Traditional airports may eventually become obsolete for shorter routes, as this aircraft's vertical takeoff and landing ability allows it to operate from compact skyports or vertiports built atop skyscrapers or in city centers. Passengers could board from a local hub, fly directly to their destination without connecting flights, and land in the middle of another metropolis all in a fraction of the time conventional airlines require. The technology behind the Model A extends far beyond flight mechanics. Tesla has reportedly integrated elements of its autopilot AI and neural net system technologies, originally designed for cars, into the aircraft's navigation and safety systems. This means the Tesla aircraft can analyze air traffic, weather conditions, and optimal flight paths in real time, reducing human error and increasing efficiency. In theory, the aircraft could even operate autonomously, with AI managing takeoff, flight, and landing. Musk hinted that the aircraft's cockpit might not even resemble that of a traditional jet. Instead of complex control panels, pilots or perhaps future passengers might interact with a large central interface, similar to Tesla's in-car display but far more advanced. This digital cockpit would provide live telemetry, global positioning, and environmental analytics, all processed by Tesla's next-generation Dojo AI chip. One of the most ambitious aspects of the Model A's design is its focus on urban integration. Tesla envisions a future where every major city has networks of vertical takeoff zones, connected seamlessly to the existing transportation grid. These zones could act as both launch points and charging hubs, using renewable energy sources like solar and wind to power local infrastructure. This would effectively transform air travel from something exclusive and industrial into a more personal, everyday experience, much like how electric vehicles turned high-tech mobility into an accessible reality. Musk also addressed the potential safety concerns that naturally arise with such an advanced concept. The Tesla aircraft incorporates multiple redundant systems, ensuring that if one energy source or propulsion unit fails, others can instantly compensate. The electromagnetic lift technology, unlike traditional jet engines, doesn't rely on combustion, which means there's virtually no risk of explosion or fire. Additionally, the aircraft's exterior shell is built from ultra-lightweight titanium composites and graphene layers, providing both structural strength and thermal stability at supersonic speeds. From an environmental perspective, this aircraft could be the biggest leap towards sustainable aviation in history. Airliners currently consume hundreds of billions of gallons of jet fuel annually, producing massive carbon output. If Tesla's technology scales, the Model A could not only replace current jets, but make aviation one of the cleanest forms of long-distance travel on Earth. Economically, the ripple effects could be just as profound. The Model A could completely redefine how airlines operate. Instead of centralized hubs and massive airports, we could see decentralized networks of smaller, localized flight centers. Ticket prices might drop drastically due to lower energy costs and simplified infrastructure. Entire industries, tourism, logistics, global business could accelerate as travel becomes cheaper, faster, and carbon neutral. Tesla's announcement also sends a strong message to competitors. Aerospace giants like Boeing, Airbus, and Lockheed Martin now face the challenge of reinventing their own technologies to keep up. Meanwhile, governments worldwide will have to rethink airspace regulations, urban planning, and environmental policies to accommodate this new form of flight. Critics, of course, question whether such technology can truly exist in the near term. The idea of manipulating electromagnetic fields to generate lift still borders on what many consider science fiction. However, given Musk's track record turning electric cars into the mainstream, landing reusable rockets, and developing AI-driven energy systems, it's hard to dismiss his claims outright. Time and again, Musk has proven capable of turning impossible ideas into practical realities. If Tesla succeed.